Hello, in this video we're going to be talking about the pH scale, which also includes acid and bases. So let's not waste any of your time. Let's get right to it. Now, as we mentioned in our previous video, pH or acid and bases, these are just a byproduct of water molecules naturally, spontaneously separating to where we have the one hydrogen by itself, which has lost its electron and only has a proton, and the hydroxide, which is the OH, the other portion of the water molecule. Remember, H pluses become the acid and the OHs become the bases. And based on how many of these there are, determines kind of the strength of the base or the acid. And bases or acids are not strong or weak by general, comparatively to each other. I mean, you could be a super strong base and a weak acid. You can be a strong acid and or a weak base. Excuse me, I got something in my eye. So neither are stronger or weaker than the other. They are strong or weak in their own area. The idea of the pH scale, and the pH scale is simply a numerical expression of the concentration amount. The stronger acids are the lower numbers, the stronger bases are the bigger numbers. And as you go from one level to the next, it isn't just a slight increase, it's an increase by 10%. Same with the magnitude scale for earthquakes. A level 1, okay, and then we have a level 2. A level 2 is 10 times stronger than a level 1. A level 3 is 10 times stronger than a level 2. Same with the periodic table. If you've, again, had a chemistry class and you've calculated pHs and OHs and the alternate of those, you're well familiar with the strength, but it's a measure of concentration. Okay, when we look at the pH scale, and again, as you can see, this diagram has not only the pH levels, but a common item found at that level. So feel free to draw that diagram and to list those out. But just some general characteristics of the pH scale. 7 is neutral, and again, hopefully that's not news to you or new news to you. But 7 is neutral. That's where a lot of our systems inside of our cells like to be. Blood, water, the plasma, anything like that likes to be in kind of that 7 ballpark to be neutral. Anything lower than that is an acid on the number scale. Anything higher than that on a number scale would be a base. And as we talked about, the lower you go as a the lower you go as a acid, the stronger you are. The higher in numbers that you go as a base, the stronger you are. But that's the idea of the structure. Okay, a look at some acids and their strength level. Again, if you are a low number, a 1 or a 2, you're a very strong acid. If you are a 6 or a 5, you are still an acid, okay, but weaker than the other ones. And again, acids are the hydrogens portion of a water molecule, and they will reduce the pH. So the more hydrogens you have, the lower the number. And again, it's a concentration amount. In other words, the stronger you are as an acid, that means the more hydrogens that you have. It isn't that an acid is strong just simply because of its composition. That is what it's made of, but it's a calculation of the number of hydrogens it has with that. So if you were to take a particular acid and add more hydrogen ions to it, then you would change its strength level, and you would also change what it is. But again, here's some examples of strong or weak acids. Now when it comes to bases, okay, the same thing is true. You can have strong bases, you can have weak bases. Bases tend to be a little more in the cleaning field, whereas acids typically are found more in foods, mainly because of the citrus family. But you can see you can have some bases. Again, these are going to be above 7 on the number scale, and these are a calculation of the number of OHs found, the concentration of OHs found in the molecule. So you can have some bases that are extremely strong. Okay, an ammonia cleaner, you would not want to drink that. But you could drink some baking soda water. I mean, that's a 8, upper 7, low 8 baking soda water. I mean, it wouldn't taste great, and there's no real need to do that. But you could. But a Drano, which would come across as an 11 or 12, you would not want to drink. So you can have strong bases, you can have dangerous bases, you can have dangerous acids, or you can have weak ones as well. Well, that's our video over the pH scale and the acid and bases, and this also concludes our videos within chapter 2. So again, the next time we come together will be will be chapter 3, which will be talking about the macromolecules within the cells, the carbohydrates, proteins, nucleic acids, and the lipids. So we'll see you then.